So on the got it that we just left off on, this video will be part 5, but we're going to wrap up part 4 real quick. On this got it, the biggest change here was we wanted to see when the population would be 275,000. So I changed my second function to 275,000. Actually, my original function stayed the same. I thought that initially that 1950 was something different, but it was the same as our example problem. So if you have the window that I set last time, this should fit on that window. I should still be able to see my horizontal function and my cubic function. So again, I'm going to go second trace to get to my calculate menu. I'm going to go down to the intersect tool. Now it's hard to see because now my function has come up. So if I want, I can make things a little bit better. And let's make my y max. I just kind of like to be goofy with the numbers occasionally. We can do that and graph it again, and now that'll shift it down a little bit more. So now when I second trace and try to do that intersect, I can actually see what I'm doing. So try my first curve and my second curve and my guess point, and I see it's 1999. Let's see if that's what they got. We get 1999. So if you have been doing your work correctly, you should be finding the same intersection point as me. Moving over into problem 5.
In this problem,
sorry if that was really loud for you guys. So you have this shown on your notes. So we're just going to look at this for a second and then try the got it. So notice that the 2 is the compression factor that will bring your graph either towards the x-axis or away from the x-axis. So since it's greater than 1, it's going to push us away from the x-axis. My +1 is going to be that horizontal shift. It'll actually shift it to the left 1. And that -4 is actually going to take me down 4. So you can see this blue graph is actually the final graph of our function after the compression factor, horizontal shift, and vertical shift. So now try this value. We have 3 minus 1/2 of the cube root x minus 2. So go ahead and give that a shot. Think about, well, if this 3 is outside my cube root function and it's not a coefficient, what is it actually doing? So try to make a hypothesis before you type this in your graphing calculator of what is that 3 going to do. Pause the video, because I'm not going to stop the video. Pause the video, think about it, write down your guess, graph it, and come back to see what the final result is. So I'm just going to go ahead and do this in my TI because we use Desmos a little bit. So I'm going to clear this out, and before I forget, I'm going to go zoom standard to take my window back to normal. So I'm going to go back to my y equals menu, 3 minus the 1/2. So I'm just going to do parentheses 1 divided by 2 times the cube root function. So again, go to your math menu to find your cube root. Down to cube root. It's x minus 2, so I type in x minus 2. Close that root. And now we go put it on the graph. Now what did this do? Did this actually happen correctly? So if I go and look at Pearson's result, get all the way through here. So there, 3 minus 1/2. It shifted up because the 3 is actually a vertical change. It shifted right because the -2 actually takes me to the right 2. And the 1/2 condensed it. And then the negative actually flipped my function over the x-axis. So now I would have been above the x-axis going to the left, and I would have been below the x-axis going to the right. But notice they're both above the x-axis now because that vertical shift that we took. This is correct. It's just a little harder to see. If we want to really see where the center of the function would have been, we could zoom box if we wanted. We haven't talked about a zoom box, so I figured I'd show you guys this. So if I go up to some point, let's say a y value of 5 or something like that, and I shift over and then down, it's actually going to make a box. And it's going to zoom me in the best it can there. So there I can see there's the center of my cubic function, kind of that S curve that we were used to before. And if we then trace it out, we can see that that shift has happened. So honestly, when I go to graph this, I could have just made this a -1/2. And then I could have just added 3 over here. And it should get me the same graph, you'll see, because the 3 is outside of your radical, we could have added it after the radical, or it's really being added before the radical over here. There's only going to be one more section, so assuming you still have time, go ahead and come back to the next video for problem 6.